Alright, in this video we're going to talk with the help of integration by substitution, or one part of the techniques of integrations is helping us in integrating some trigonometric function which can be using formula. And for this case, integrate tangent x is still okay because we can using formula. As I suggest that you can using this formula as well. Alright, dear student, you can using this formula. Alright, you can try using this formula, because as you know that integrating tangent, there are no formula in integrating tangent. You only have integrating sine, you're getting negative cos. Integrate cos, you're getting sine. Integrate secant square, you're getting tangent x. Only three formula, but none of the formula is integrating tangent. So it means you need formula or a techniques to deal with this integrand. So as I said that integrating tangent, you have to write it out in the ratio of sine x to cos x. You have to writing this in the form of sine x to cos x. So you can using this formula because you know that as differentiating cos x, you were getting negative sine x, right? Cos x, you were getting negative sine x, fx. So you just put a negative and negative here, then you can get negative ln cos x plus c. Okay, with this formula will be faster. But formula is not, sometimes you may confuse, right? So you can apply techniques. So the techniques here is very simple. For tangent, we were always choosing u as our the denominator as our substitution function. So where I will du dx differentiate, as I differentiate cos, I getting negative sine x, right? Where I can see that there is a sine x dx here. Okay, so I will divide, I will bring the negative go to the left hand side, and the dx I cross over there, sine dx. Why I bring negative here? Because I can't see a negative here, right? But I can see sine x dx is in the integrand, right? I can see that sine x dx is in the integrand, so which I can replace by negative du. So as I integrate, this whole thing will become du, and here there is a 1 over with cos x. Cos x is u, so you have 1 over u. Become very simple. Integrate, just like integrating 1 over x, you're getting ln modulus x. So for this case, you're getting ln modulus u plus c. As the u, you can replace with cos x. Alright, you can replace with ln modulus cos x plus c. Alright, let's move on for the next example. Alright, okay, integrate cotangent and integrate tangent, they have a very similar techniques. Alright, so where because tangent is the ratio of sine to cos, and cotangent is the ratio of cos to sine, right? As you can rewrite this to be the integration of cos 2x divided by sine 2x. As you're very familiar with trigonometric ratio, cotangent is defined as 1 over tangent, or as cos over sine 2x. And for differentiating tangent part 1 or cotangent part 1, we usually asking students to choosing the substitution function as the function in the denominator. So means that for these cases, I will choose u to be sine 2x, because as you're differentiating sine, you get cos, right? You're getting cos, so it can be replaced, but everything in terms of u. So let's differentiate u. So du dx, du dx. So you have differentiate sine, you have cosine 2x, right? And don't forget your knowledge of differentiation. You have to differentiate 2x, you're getting 2, right? So then you have du over 2. I just bring the constant here. And I have cos 2x, and this dx cross over there, you have dx, right? Then you can see it's exactly the same like you integrating tangent. You can replace the cos dx, the cos 2x dx with du over 2. Cos 2x dx with du over 2. And this will be 1 over u, right? because sine 2x, right? Sine 2x u. So I can factor out the 1 over 2 of the bracket and integrate 1 over u du. So exactly, you have 1 over 2. As you integrate 1 over u, you're getting ln modulus u plus c, right? U, and the u is sine 2x. Alright, I remind you again, integrating tangent to the power of 1 or cotangent, we're using the method of substitution. Right, okay, let's move on for more examples. Right, okay, let's move on with these examples. So where there is x power 4 cos x power 4, it seems like very complicated, right? But once you're choosing a right substitution methods, it will help you solve this very easily. So you cannot simply choose a suitable function. So some students will say, sir, can I choosing u as x power 4? I cannot say no, alright? Because if you're differentiating x power 4, you're getting 4x cubed. I asked the student, is there any x cubed in the integrand? No, right? You can't find an x cubed here. So if, okay, student will say, sir, how about I choosing the cos x power 5? Alright? So, okay, you're choosing u as cos x power 5. So I'm asking the student, if you're choosing cos x power 5 as your u, you're differentiating cos. You're getting what? You're getting negative sign. There is a sign. Sine x power 5. Do you see sine x power 5 inside here? No. So means cos x power 5 is also a wrong, it's not helpful. So finally, maybe the student were choosing x power 5. So I said, you try, okay? You just try. So, so as a student, you must try and making mistakes so that you learn something. So I will try u x power 5. But I can tell you this is true. This is definitely correct. Why? Okay, I differentiate. After differentiate, you will know. Differentiate x power 5, you get 5x power 4. Can't you see there is an x power 4 here, right? Yes or not? So it means you are choosing a right function. So in order you're asking your teacher, it's better for you to think why you're choosing. Okay? So this is the way that you study mathematics. So du over 5. So x power 4, this one cross over there, dx. Beautiful, right? As you can replace, okay, I can rearrange this as the x power 4. I can group together with dx, right? X power 4 with dx. So which is du over 5, right? Du over 5. Done. For this, I have replaced the x power 5 with u, right? So it becomes a very easy integral, right? So you can take out the 1 over 5. Then you just integrate cos. The basic formula, integrating cos, what do you get? Integrating cos, you're getting sine u plus c. Then you have to replace the u, as u is just a helping function for it, help you to integrate better. So then you replace it, you become x power 5 plus c. Right? Then you can doing this question very easily by choosing a helpful function. U equals to x power 5. Alright, okay, let's move on with more examples so that you know the way of solving integration by using the technique of substitution. Alright, okay, let's move on with these examples. So you try to observe this and start choosing a right substitution function, a u, in helping you integrate something like this. Alright, it's considered complicated if you don't know what is the techniques here. Alright, and this is also can apply the formula, right? Apply the formula. You can apply the formula of if you are a formula lover, some students they like formula, so they will be applying formula. But formula is not a technique, so it's not so powerful, right? It's fixed, right? Something that fixed. So it means that you have f prime fxn, then this is the formula that you can use. So I'm not going to tell you how to doing this. I'm just telling you that your fx will be your sine 6x here to the power of 2. right? So now mainly I want to talk about technique of substitution. So, okay, you can pause the video and try first. Okay, now you can see. So now you have cos, you have sine. Definitely for me, I was choosing sine 6x. I was choosing sine 6x. I won't choose the square. I won't choose the square because if you're using square, you were getting, you will differentiate, you were using power rule. So as you differentiate, you were getting something that very complicated, right? So for me, I was choosing sine 6x because why, right? You can try anything that you want, but in this video, I suggested that you writing out the square and you have cos 6x dx. Okay, why? Okay, let's see. Then you will know why. So du dx, okay, du dx, differentiating sine 6x, you will have cos 6x, definitely, right? Differentiate sine, you have cos 6x. Then you can see there is a cos 6x here. So are you happy? You happy, right? So then you're differentiating the 6x, then you're getting 6. So du over 6. Du over 6 is the same as cos 6x dx. You will be happy if you're choosing u as sine 6x. So then you can replace this whole thing. Everything with du over 6, right? Du over 6. And definitely this one you can replace with u to the power of 2. Wow, it's a lot easier compared to this, right? So this is a powerful of integration by substitution. So 1 over 6, integrate u square du. So 1 over 6, integrating u square. So it's become u power of 3 over 3 plus c, right? U power of 3 over 3 plus c. 6 times 3, you have 1 over 18, right? 1 over 18, and u to the power of 3 plus c. Wow. What is u? U is sine 6x, right? Sine 6x. So which will give you 1 over 18 sine cube 6x plus c. So with the techniques of integration by substitution, I can solve this easily. Alright, okay, let's move on for more examples. Alright, okay, let's move on with these examples where we want to integrate sine cube dx, right? Sine cube dx. So if this is a cube, so there is a special techniques of integrating a cube, either is by using the formula, the compound angle formula, which you have to derive such that sine cube can convert it into a linear power 1 with a linear function for trigonometric in trigo form. So but this is sine cube x, right? Sine cube x. So another way of using this is by using substitution method. So how we're going to do is the method that I'm going to introduce you here will be, you're going to rewrite this in the form of sine x dx, right? So means that you split this thing, becomes sine square sine x. As you multiply this, you get back sine cube, right? Then based on this, this is the odd power, right? Odd power. So means power 3, power 5, we are applying this. So, okay, you have to choose, because this is odd, so we have to choose, we look at this here, after we splitting this, we see that there is a sine x here, right? So we choose the u such that it's opposing sine x, which when you're differentiating cos, you are getting sine, right? So you're not going to choosing sine x here, because if you're differentiating sine x, you're getting cos x, which is not inside here. So this type of cases, odd power, we are using this type of techniques. So du dx, and you will have negative sine x. So, and du, negative move over there, and you have sine x dx. This is the purpose why I choosing cos x. Alright, but the student will ask, sir, if you're choosing cos x, there are nothing here you can replace by cos x. No, you have to think why. Alright, so as this thing, sine x dx, you can replace by negative du. Alright, so this is done. But for this, you say, teacher, there are no methods that we can replace. Why you are choosing u equals to cos x? That's why we have to understand the trigonometric formula very well, as we know that one of the formula will be sine square x plus with cos square x equals to 1, right? Identity, the Pythagorean identity. If you know this formula, you know that sine square can rewrite as sine square x can rewrite as 1 minus cos square x, right? And you know that cos square x, cos square, so you will be 1 minus u square, which can, alright, can be solved. You can replace this one but with 1 minus u square. Alright, why? Because sine square, you have to state this, sine square is 1 minus cos square, so you can write y minus u square. So now you can see that it can be easily integrated. So negative can multiply into the bracket, you have u square minus 1 du. Right? Negative, positive, negative 1. So integrating u square, so you have u to the power of 3 divided by 3, right? Divided by 3 minus with u plus c, right? So what is u? U is cos x, cos cube x, alright? Cos cube x divided by 3, right? And minus with cos x, u, cos x plus with c. That's the way we solving a problem that involving odd power, sine cube x, alright? So as I said in the previous lesson that in the part of trigonometric integration by integration of trigonometric function, I have mentioned about integrating sine square, right? Sine square we're using double angle formula, right, for cosine. So for odd power, this is the way we do, it's faster. Alright, so let's I will give you more examples so that you have better understanding. Alright, okay, same, this is a cos cube and just now is sine cube. They apply the same techniques. Alright, so you're going to, okay, this is a preferred techniques that I teach you, so I hope you can understand. So as you can split this, as you see a cos cube, alright, you can split this to be a cos square half x and a cos half x, right? As you know that with this and this, you multiply, you're getting power of 3, right? So what I'm going to do now will be, I'm going to apply, this is odd power, so I see that this is a cos half x here. So I have to think, what is the suitable function of u so that when I differentiate, I will getting cos, right? I know differentiating sine, we're getting cos, so I'm choosing sine. So this is a technique here. So I choosing u as sine half x. So then I just differentiating this. As I know that differentiating sine, you're getting cos, right? Cos half x. And don't forget to differentiate this, you have 1 over 2. Then you can see, as long as you see cos half x, you will be happy, right? You know. So, and these two cross over there, become 2 du, and this one cross over here, become cos 1 over 2x dx. And nicely you can see that this can be substituted by 2 du, alright? Integration by substitution. So you have to substitute this whole thing with 2 du. And I said this is done, right? And for this cos square half x, this is only sine half x. So how to relate cos to sine? So there is only one, because there is cos square, because sine square theta plus with cos square theta is equals to 1, right? So I can replace, because I need cos half x square, right? So I just write everything here to be sine square half x plus with cos square half x. As long as these two angles are identical, so sine square cos square, it will be 1. So then you can see that cos square half x can be replaced by 1 minus sine square half x. Then you see that sine half x, alright, sine half x is u. So it means that you can convert this into 1 minus u to the power of 2, right? You can 1 minus u to the power of 2, and you're replacing exactly inside here, okay? 1 minus u to the power of 2 and become 1 minus u to the power of 2. Now you can see everything in terms of u. Okay, this is the proper way of doing integration by substitution. So, okay, just write the 2 and integrate 1, you're getting u. integrate u squared, you're getting u cubed over 3 plus with c, right? So then you have 2 integrating cos. U will be sine half x, right? Sine half x minus with 1 over 3 sine cube half x plus with c. Alright, so I have introduced you for integrating sine cube or cos cube. You are applying these techniques. Alright, okay, I think that's all for this video. So I will do another video for integration by substitution, which is involving the finite integral. Alright, this is indefinite because you don't know what is the limits. Alright, you don't know. That's why we have a plus c here, right? So it's general. This is a general solution. So let's say you have if you have a limits here, then you know the solutions. All right, you know that you can evaluate this integral. All right, I will talk about that in the next video. All right, that's all for this video.